So I'm Philippe Koval, and thanks a lot for joining this event, a live embedded event. And today I will speak about some use case where privacy matters in an Internet of Things architecture. So let me introduce myself first. So I'm a professional open source engineer. I used to work for big industry players like Tizen operating system for Intel. Then I work on Yocto on automotive project, and then I was able to join a Samsung open source group, and one of my contribution is a contribution to the IoT framework for interoperability in IoT. So currently I'm a contributor in open source project. I'm part of Mozilla Web program involved into IoT project, and I'm also contributing to Debian. I used to contribute to Qt and also the NetX RTOS system. So here is my address. If you want to contact me at this address, pearl.org, you will find all of kind of channel to reach me, and I'm currently available. So if my work are inspiring you, feel free to contact me. Maybe we can do things together. So I'm based in France. I can answer question in French if you want also at the end. And yeah, you can link me and see some updates about what I'm doing. So I shared a lot of demonstrations, some videos, and some updates about my contribution in the open source. So let's get back to the past and try to identify where Internet of Things began. So I think it started around the year 1984. That's an interesting date, but let me share some experiments some students made with a DIY Coke vending machine. So it looked like this, and I believe those are the people who set it up. And it was connected to the internet using this kind of hack. So that's pretty similar to what people are using today with Raspberry Pi and connecting probably some relays to for the dispenser. And it also is some kind of UX, because using the old finger protocol, you can check how many items are into the machine using a command line. And what happened today? So, okay, there was a lot of product on the market, and let's see if our promises are really achieved. So do we have today a lot of interoperability, or is it just a bunch of silos? Is the security model respecting also privacy? This means if you have everything in the cloud, is it maybe it's safer than having some device people can get into it, but at the same time it can have some side effects on privacy. So what we have today, usually the regular business is to connect the device to a cloud operator that will give you to the user an app to run on his mobile phone to control his device through the cloud backend. So now I have some open question for, it's about IoT, but it can be also applying to any things online. So how strategic is your home or your family or just your health or basically just your data? So that can describe your life, isn't it? What are you gaining with this kind of system, and what are you losing? That's a question I think it was to be asked. Who should you trust or delegate your system? What about data harvesting, collecting your personal data and selling it online to other business? What happened in case of data leakage? And something you should keep in mind that everything is costing money to run it. So that means that somebody has to pay for it. And how reliable is it? If a system too much connected to the internet can fall down, how do you survive this situation? Is today regulation or the cybersecurity involved enough to protect your strategic assets? What about just resilience? I'm talking about what could happen in 10 years, and what can happen regarding your digital sovereignty. So this can some questions that could apply to big organizations, for instance. So in the end, I believe that we have some kind of dilemma between the technical answer and the cultural background of people making decisions. So I think that's a question, that's a kind of choice we are doing every day. So yeah, keep this in mind and try to see what's match best your needs. So hopefully, let me mention about some regulations. So I'm French and so based in Europe, and we have this GDPR. That's a big text, but there is something that I've noticed that can be really interesting is this Article 25, which try to convey service operator to run their system with privacy by design and by default. That's really something interesting, and it can be a really good opportunity for free open source software and communities, because privacy is part of our community DNA. That's the kind of value we are pushing since the beginning, probably. So the challenge we have today is how to do Internet of Things with privacy. So we want to do something user-centric and obviously user data-centric. And how can it be decentralized to be more resilient? So let me now mention some privacy by design principles. That's something that's been proposed many years ago, but it's worth to mention them. So the first one is try to be proactive and not reactive. This means try to fix the problem before that occurs. Privacy should be the default. So it should not be an option, and it should be part of your design at the beginning. And for this, you can, I lost the focus. So yeah, in the end, your user should have the seamless experience. If privacy is well handled or bad handled, it should be the same. So it's quite difficult for people to know what is going on from the UI. So if you are committing to provide privacy, that's a kind of trust you can get with users. And when security, of course, because if your privacy is not secured, that's a problem. Visibility and transparency, this means keep it open. This means open implementation if it's software, openness of when the trouble are occurring, what are the fallback plans, and so on. So respect users and keep it user-centric. So you can find more detail on this link. It's not a consensual proposal, but I think it was interesting to get the idea. So now let me mention about some technical response to this. I believe the web is a good platform to achieve this kind of problem, because the web itself has been designed for interoperability, so it's built on standard and open source software. Most of what we have today on the internet is made with free software. It's decentralized. This means you can have many servers. And you have something really interesting is that we have some kind of trusted runtime, because the application is running inside the browser, and it's some kind of container before the container we have in the Linux kernel. We have some kind of isolation. Of course, it's hardware agnostic. This means you can move from one device to another. And the UI is rich enough to create a nice application. And you can also provide seamless experience using progressive web apps. This means on your mobile phone, you can add an application as a native application, and if you click on it, it will open your browser in full screen. This means you have the same user experience. And of course, it's programmable. So we have all kind of technology like a REST API for making web services. We can also have real-time connectivity using WebSockets. So people at W3C are trying to propose something called the WebOfThings, which is a working group. We try to see how the web technology can be useful in an IoT context. So they are proposing some standards. They are not reinventing the wheel, because there are a lot of standards already on the web, like JSON, for instance, for description. There are some works regarding semantics, some WebSocket I just mentioned before. So everything we already have can be reused, but something are missing, like some kind of common semantics or unification of description about smart things. So this smart device. So they are working on a proposal, and now it's a recommendation since this year. And you can get all the detail on this address. And also there are some open source implementation like Mozilla WebThings, which is an ongoing effort. This is what I'm going to explain today. So WebThings, it's a smartphone platform born in Mozilla Emerging Technology Lab. It has been designed from the beginning with privacy in mind, and it's using a simplified model compared to what W3C is doing. So in the end, there is some hope to converge into something that match the use case for the smart home and what W3C is trying to promote in a generic way. So the project is built, is composed about a framework to build WebThings. So WebThings are basically just HTTP server, they are standalone device, and they are talking REST API, and you can just update, create some properties and trigger some action to the device or listen to action from the device. The key point of this project is a gateway software. So it's an headless application where we try to connect all the things together and to provide all the functionality to control all the things together and try to provide a rich UI for the user and try to also do some automation. And if you are going to the GitHub project, you can download the pre-release version, so it's something expected to be released in the coming days. So here is just a picture that's explaining what we have on the right. So this is a typical application, the typical smart home approach. So we have all your device home, of course. They are connected somewhere on the cloud, and your smartphone is acting as a remote, and you can control your device using an application, probably many applications, because many devices are trying to isolate your user into its ecosystem. And what we have on the left is a similar approach, but all the data stay home and there is no cloud involved. The only option you can get access to using the internet is just by creating a tunnel which can connect to your device from the outside. So, but if you are staying home, you can connect directly to your gateway software. So the WebThing gateway, so as I said, it's a web application and a headless server. It stays inside your home network. It will run inside your home network. So you are in charge about deploying it. There is nobody else involved. It's easy to deploy because we are supporting a reference board, which is a Raspberry Pi. The project is providing a SD card image, so you can just dump to SD card, plug into the Raspberry Pi, turn it on, and it will ask you a couple of questions to set it up. And if you are a Linux hacker, you can also deploy using some packages or just reboot from scratch or use a Docker image. That's something it's also supported by the project. So the WebThing gateway trying to connect all the WebThings together. So we have a kind of star architecture. So the gateway is at the center of the star, and all the devices are each on each branch. And to make it useful for the user, we are providing a user interface where people can just trigger on and off devices, and also do some basic automation and logging what is going on inside your home if you want to analyze it later. But it doesn't stop here, because it has been designed to be extensible by design. So it's supporting some kind of add-ons to support a lot of other devices or online services. So privacy is the core of the project. Everything runs in your home network. You can discover the device using some MDNS request. The same thing you are probably using on Linux using ZeroConf, for instance. Device can be shared also to other applications where you can control them from the gateway using REST API or WebSocket if you need real-time connectivity, and if you need to have some control about users, you can issue some web tokens for each class of device. So this means maybe some application can control some device, but maybe your kids are allow, for instance, to turn on and off the light, but maybe not play with a washing machine, for instance. Security is handled at the gateway level. The gateway runs the same network of your devices, and data stay on the gateway, so it's at the edge, not cloud are involved yet. Optionally, you can open a remote access using a tunnel. So it's using a Let's Encrypt certificate for HTTPS, and PackageKit is a software used for opening the tunnel. Now let me show about a very basic example how to create a WebThing. So there are several libraries. So here is a JavaScript one for the Node interpreter. So if you clone the source code and you run the simplest thing, which is just a switch, it will run a server. And if you make a request on the default endpoint, you have the description about the thing. So the thing is using a schema to describe what it is composed of. It is a set of capability, and each capability has specific properties. So like the on switch has the on properties, which is a boolean, just to turn on and off the switch. So that's the basics to define what is our thing. So if you make an HTTP query on the thing itself, it will return the value of the thing. So the endpoint is property/on, and the result is a value which is on set to true. So if you want to turn off your thing, you can just make a HTTP put request on the same endpoint. You pass JSON structure which is setting it off, and it will set off accordingly. So this is a very basic, the minimal one. If you want to create like a light bulb, it is composed of a switch, obviously, but probably it has a more the focus is gone on my screen. Okay. So if you are creating a light bulb, you probably have an on switch, but you can also have a user properties like the color. So from the UI of the WebThing dashboard, you can control each properties using a different kind of widgets. So that's something user-friendly. You don't need any apps. That's something you can run just on your browser. If it's running on your phone or whatever device that can have a screen, you can interact with it. Now let's mention about add-ons. So today we have over 130 add-ons. That's a pretty lot. Most of them are coming from the community, but let me mention about a few just to give you an idea about what can be done. So we have virtual WebThings. So basically, they are just a stub device. We can just use them to simulate the things. So if you don't have any device to get started, that's something really useful. We have a URL adapter, which is discovering all the WebThings in your home network, like the one I just shared before. So you can create your device yourself using your favorite language. We are supporting Arduinos, C++, JavaScript, Rust, and so on. But you can also support other devices, something you can find on the market, because some of them are using standard protocol like Zigbee or Z-Wave, Bluetooth, also on-vive camera, and so on. So it's easy to map all those devices to, like if there were native WebThings, you just need to translate the protocol. But it doesn't stop here, because we can do a lot of things like creating some kind of things hosted on the gateway. Like if you want to put some sensor on the gateway, I made an adapter called the generic sensor adapter. This means you can monitor the temperature without building an extra device. You can just use your gateway as a thermostat, for instance. Also, you can interact with social web, like I made the ActivityPub adapter, which is posting updates to Mastodon network. You can send updates by email or use community information online, like OpenStreetMap. I think we made a hack with OpenStreetMap also. Let's say if you want to get some update about the opening hours of some kind of shops, that's something doable. And you can do all kind of logic between all the things, trying to automate them. You can do some condition using a calendar, for instance, or timer, clock. And you can also deploy a voice adapter, which is using Mozilla Deep Speech. So here's a short demonstration about the Activity Pub. You get an idea about how does it work. So I can do some voiceover. So I'm turning on this matrix LED. I can control the color, turning on and off, and so on. And this has been done using the adapter. Here I'm using another adapter like this Activity Pub adapter. So it's installing now. It will be able to post to my Mastodon network. Let's say if I'm away and I want to send a notification to my neighbor to check something, or to if my sensor is detecting something that can be valuable for the community, it can be used. So once it's installed, you need to configure it. So here is a Mastodon configuration. So I need to issue a token for connecting to my social account. So I need to create an application. This is not specific to WebThing. This is Mastodon. So I have a token for this application. So if I'm copying this token to my Addon, it will be able to use my account as a client. Let's get back to my dashboard. So here I'm adding a new element like this Activity Pub device. It's not an actuator because it can work also as a sensor. So I'm fixing the name. I'm adding an image for display, and here it is. So if I'm getting into it, there is only a single property, which is a text. And if I'm changing this text property, and in a second, it will update to my Mastodon feed. So this has been done manually, but I can also do some kind of automation. So I'm using here another add-on, which is a follower add-on. I have modified it a bit to make some kind of connection to use a matrix LED as a display for my latest updates on my Fediverse feed. And it works both sides, because if I'm going to my Mastodon account, so this is application if you want to get started, but let's reply to my latest tut. So if I'm answering, no, it's not an actuator, it's also a sensor, and I'm pressing it from the web. Then if I'm looking at the property, it will update in a second, and it will also be copied to this other WebThing, which is a sense@, for the Raspberry Pi. So if you want to join our community, so that's pretty easy. So usually originally it was a Mozilla project, and now it's moving to a community, its own community. So the portal is webthing.io. In a few days, you'll probably see more content, but you can get access to the source code and all the side project. And you can, if you need some kind of support, don't hesitate to join the chat room. We are using Matrix, and the forum is also open if you need more async support. It's hosted on Mozilla. You are free to join. And to get started, you can try to look at what add-on has been shared to the community. There are some devices and services, and it's a good way to get started. And now I can also mention about a related experiment, because I believe that WebThings, it has been created to address some smartphone use case, but it's flexible enough to do more than that. So let me share some experiment I've been doing for a couple of months now. It is, I call it the WebOfThings, how to make the Internet of Things work in a 3D world. So what you see here is the same Raspberry Pi with a sense@, and on the left I have this virtual world called Mozilla Hubs. So it's a shared world where many users can join together. Here I'm joining using a phone, but you can use also a VR headset, and you have a very good immersive system. All users can join the same world and talk together because it's supporting voice. You can chat with other people, and what I wanted to do is trying to put a physical object inside this virtual world, like this toy house. So I'm moving it in a different, in a reality, and it will be updated to each users in a semi-real time. So that can be really convenient, especially if people are locked down and if they want to share some physical assets we are not accessible because only a few person can stay in the same room. So for instance, we are in this COVID situation where there is a lot of restriction. This is a kind of technology that can be really interesting to push this forward. So even if the actual thing is not existing, you can just use it, let's say, a virtual web thing as a stub to create the application. So what we have on now on the bottom WebThing view is a view of my sensor device I have on this sensor, so I can monitor the temperature, the pressure, and so on. So this is some great experimentation hardware to get started. Now I think yeah, I can change the color to trigger some kind of condition and actions and so on. So yeah, you can check the slide later. There is a couple of other demonstrations, and you can get access to more links about others demo. Cool. So we are near to the end of this presentation. So let me make a short recap. Privacy rely on the trust of your infrastructure, basically. So if something you are running in your home inside a place you trust, it can be more a better choice. The web itself is something decentralized and extensible, and so we were able to address IoT use case using this WebThing platform. It's something for made smart home, so you can connect all your devices in a safe way. It's easy to interact and automate them. And it's extensible to address more use case like interact with any other services online or even to remote things and so on. And I believe that the WebThing API is simple enough and flexible to address other use cases like this WebOfThings experiment. There is also the microblock project, which can be really interesting if you want to target academics or schools to get started and to have physical feedback about their things. That's something interesting. And mixing Internet of Things and VR, that's something really fun to do, and you can use this Mozilla Hub project also as a platform. So now I can share more details of if there is any question. Okay, there are some questions in the chat room. What other supported transport later, like the one I am supported? Okay, so LP1. So I hacked some kind of WebThing using a LoRaWAN device I have. The problem is that it's not a technical issue about integration because it's well designed. The problem is about more the semantics, like LP1 is usually a restricted payload, so it could make sense to use something binary and something standardized. So there are some effort. I know that Open Connectivity, for instance, try to address this. But if you want to do this for your own use case, that's totally doable. If you are creating your own format, it's just easy to implement. I believe that any others protocol should be able to be used. So the problem is more now integration side. So if you can connect it to the gateway itself, like if you are using a serial adapter, for instance, my LoRaWAN was a modem using a UART, I can connect to it. That's not a problematic, but if you want to connect several, maybe it could make sense to have another device that will implement the WebThing API. So this way you can have a seamless experience. The question will be just about to align the description about what you're going to transport. So basically, I could say it's not that difficult because we are always speaking about the same thing. For instance, a temperature is temperature, but probably there are many standards which are describing temperatures in own way, so you need to pick one and try to align. For this, Mozilla is proposing their own schemas. It's something made by the community. I know that also there is a proposal on schema.org, and the W3C is also trying to address this. So from a community point of view, you can try to propose something that align your use case and translate it to the web way to do it. So if it can fit in a JSON description, you're fine. I'm looking back if there's any other questions. I think there are some focus issue with this application. Sometimes it's telling my focus, but I'm far. I'm 2 minutes late. Sorry for that. And if you want to watch more demos and video, you can just bookmark this link. You get some access to the video of my presentation. And thanks a lot. And goodbye. Now I'm turning it off. And see you at WebThings channels. Bye bye.